I would like to show you that linear factors of polynomials give the x-intercepts. But before we do that, let's do a little review. I have an equation here that's y equals x squared minus x minus 6. And this equation is standard form. It has a name. It's degree 2, so it's quadratic. It's trinomial because it has 3 terms. Standard form is also sometimes referred to as expanded form. So if you're taking the SAT or you're taking another class in pre-calculus or calculus or at community college or at another college, you may hear this term expanded form instead of standard form, and you should know that they are synonyms. Okay? Now, if we have this quadratic trinomial, fill in the following information. What are the possible number of turning points? 1. What is the right-hand end behavior? The first term is positive, so it's up. The degree is even, so the left hand is up. It's a second degree, so how many possible x-intercepts or zeros are there? 2, or 1, or 0. Okay, very good. Now, the last thing, when we're in standard form, what does the constant term tell us about the graph? What information does the constant term give us? The y-intercept. So we know 1, 2, 3, 4, 5, 6 before we even start that it's going to cross at the y-axis at 6. No, it's not 6. What is it? Negative 6. Goofball. 1, 2, 3, 4, 5, 6. Negative 6. And we know the right hand is going to be up, and we know the left hand is going to be up. Based on this picture so far, how many x-intercepts are there going to be? Yeah, there has to be 2. Nice. Well, the problem with the standard form is that this doesn't tell you where those x-intercepts are. Yes, Carlasia? Does this give the number of x-intercepts? It tells you the maximum possible number of x-intercepts. Yep. Okay. Well, what's kind of cool is that if we factor the standard form, we can find the x-intercepts. And so let's start by factoring this. There's no lead coefficient, so we know we're going to have x and x. We need to find factors of 6, 1 and 6, 2 and 3. And we need to find a way to get them to multiply to negative 6 and add to negative 1. Okay, good. Now, when we're on the x-axis, what is the value of y? Oh, when you're on the x-axis, if you pick any coordinate on the x-axis, what's the y-coordinate? 0. So we know that x-intercepts occur at y equals 0. So if we substitute 0 in for y, 0 equals x plus 2, x minus 3, and we solve this equation for each of the x's, we can find the x-intercepts. What we would do is take each of these linear binomials and set them equal to 0. And if we solve those, we're going to find the x-intercepts. One of them is at -2, and one of them is at 3. Now here's my last question. Where is the turning point going to be? On the y-axis, to the left of the y-axis, or to the right of the y-axis? Okay, now this is a parabola, and a parabola is symmetric. So if it's symmetric, the turning point should be on the axis of symmetry, which should be halfway between these two x-intercepts. 1, 2, 3, 4, 5. So it should be on this line, which is 2.5 from each of the x-intercepts. So the turning point's going to be down there somewhere. And so that's what our graph will look like. Okay. Now, get your calculator out and go to y equals, and put in x squared minus x minus 6, and also graph the factored form, x plus 2 times x minus 3. When you graph these, they should be the same graph if we did our factoring right. So that's a way we can check our work. You can do a zoom 6, and that looks pretty good. Now I'd like to show you another function on your calculator. Press the trace key. In the upper left-hand corner, you'll see the equation that your cursor is flashing on, and then you'll see a coordinate at the bottom of the screen. And you can do the side arrows and slide along your equation, your polynomial, and get all the xy coordinates. Even better, you can enter an x value and get the y value. So for example, you could press 0, enter, and you can find the y-intercept, which is at 0, -6, which is what we had on our graph. We could plug in x equals 3, press enter, and confirm that x equals 3 is on the x-axis. It's an x-intercept because y is 0. We could press -2, enter, and confirm that we have the other x-intercept because the y is 0. So that's a nice way that you can confirm your work. All right, let's summarize. Standard form gives you the following information: the possible number of turning points, the end behavior, the possible number of x-intercepts, which are also called zeros, and it gives the value of the y-intercept. The factored form gives you the values of the x-intercepts. So between standard form and factored form, you can get all the information that you need about graphing a polynomial. Okay, let's do another example. If you flip over to the other side of the sheet, there's another polynomial here. So let's do the same process again. Just put this in here, standard form, expanded form, the same thing. Fill out these blanks. Possible number of turning points, 2 or 0. Right hand end behavior. Lead coefficient is negative, so it's down. The degree is odd, so the left hand is up. The possible number of zeros is based on the degree, so it's 3 or 2 or 1, but not 0. And what's the y-intercept? Well, let's look at this equation. We know that the constant term, the term without an x, gives us the y-intercept. Well, there's the cubic term, there's the quadratic term, there's the linear term. What is the constant term here? 0 plus 0. So what is the y-intercept? Yeah, y-intercept is 0. Now, do you know if the y-intercept is 0? We also know one of the x-intercepts, don't we? It's also 0. Okay. All right, now the next thing that we have to do is we need to factor this standard form polynomial. And so what I'm going to do is I'm just going to rewrite the standard form here, minus x cubed plus 2x squared plus 15x, and we need to factor that. Okay, the first thing that I notice, or that I'm going to look for, is common terms, or common factors in all the terms that I can factor out. And I see an x. So this would be minus x squared plus 2x plus 15. Now, to factor a quadratic trinomial, it's very hard to do if the lead coefficient is negative. So let's factor that negative out. So we'd get an x squared, factor out a negative, we'd get negative 2x and negative 15. Now we have a quadratic trinomial. The lead coefficient is 1, so we're going to multiply x times x. And we need to find two factors of 15 that multiply to negative 15 and add to negative 2. So let's see. Factors are 1 and 15, 3 and 5. So plus 3 minus 5. Okay, that multiplies to negative 15 and adds to negative 2. Beautiful! So to find the x-intercepts, or the zeros, they occur on the x-axis when y equals 0. And so now we solve this equation, and the way that we do that is we take each term and set it equal to 0. And then we solve each of those mini equations to get the x-intercepts. So now we have enough information to draw a sketch of our polynomial. We know an x-intercept is 0. We know there's one at -3. There's one at 5. We know the right hand goes down and the left hand goes up. So this polynomial must look like this. So now you can verify that with your calculator. And you can put in either the standard form or the factored form, or you could put both of them in to confirm that you did the factoring correctly. And that looks like what we sketched on our paper. Very good.